So on the database work, and here this is really work where I'm standing on the shoulder of lots of giants. There is it's a true community effort. Many people at IIASA and other places that really helped to develop the database infrastructure as we have it now and as we're all using it as a community. It was really nice to see here. You sit in the back and you see on several screens, you see basically people working in the databases. So that's really good to see that this is the framework provided for everybody to do the content of their work. So the few things to update you guys on. One is that there is now an official MOU relation between the IAMC, the IPCC, and IIASA to actually officially host the databases and provide the database services for the next IPCC cycle, or for the current IPCC cycle. So this includes the SR 1.5, which already has been published, but also the collection of data and the provision of data for AR6. And so this is now formalized. We have a formal memorandum of understanding between these three organizations. And then we have developed and expanded this infrastructure basically for the SR 1.5, what has been rolled out over the past few years. So to facilitate the collection of scenarios in a better way, to facilitate the data sharing in a better way, and to have more quality control, security and transparency. And I'm going to show you a little bit of what we have now, but this is really, really, really widely used. As I indicated, that you see it here in the room, but it's for many different projects, for many different teams. This is really used widely in the community, and the format has really taken off. That's also why we are thinking about extending formats to other directions. Also on the side of working with the databases, there's been lots of development of open source work packages, both in Python and in R, for people to actually process these standardized formats, and they're really out there for you to use. So if we look at what was part of the SR 1.5 infrastructure that has been rolled out, you have there, if you in the enormous data collection for the SR 1.5 that led in the end to the figures that are printed in the report. But with the report, there was then the interactive online scenario explorer that you can go to and then play around with yourself with the scenarios. But one step further, there are actually the code that was used to produce these figures is also published, and so you can go in and download the data yourself and then reproduce the figures, but also tweak your code such that you actually can reproduce the figures with slightly different configurations to look at how your current scenarios, for instance, actually line up with what was published in the SR 1.5. And that enables you to reproduce these figures and use them in the way that you would want to use them yourself. And all this is done in openly available, open source, distributed software that everybody can go into, work with, and contribute to the development, the further development of that software. So to highlight that this infrastructure has really several entry points of how you can work with the data. First of all, you can download the data, of course, yourself from the database directly. But it is also, then you can work yourself with the assessment notebooks and with other scientific software around this to process them in the way you would want them. And it's a little repetitive, I now realize, when I'm giving the presentation, actually. So on the Explorer itself, I hope that many of you have tried it. If you haven't, you should really, because it allows you to build up your own workspaces and save those workspaces where you analyze the scenarios and you analyze certain views of the scenarios and look at them in a specific way. You highlight the issues that you want to highlight, and then you can also share these workspaces with your colleagues and with others. And say, well, to tell them, like, I highlighted this specific analysis, I found this this topic, this issue. Would you please have a look at it, whether you agree or whether something else needs to be looked at? And so you can share these among yourself as in doing the assessment and in assessing researchers. And this is also linked to the documentation, to the IAMC documentation, where you can then find more information on the models and on the variables. There's lots of clicking through here from the Explorer, actually, that the definition of each variable, the definition of models, which papers are behind this, this particular study, that you can really sort of click through until you have all the information. But then if you want to work with the data yourself and reproduce the figures, there are notebooks that were used to produce the figures in the SR 1.5, and there will also be for the AR6, that you can then run yourself to really literally reproduce the figures that were used in the assessment, and then also, so not only reproduce them, but then also work with the software to actually tweak them and make them fit to your own needs. Then the software that's in the backend, that on which this whole Explorer is based around the database, is the PIAM software. That software is also available to download and work with yourself in creating your own figures and doing your own post-processing of data from the database. And so this resource is also incredibly useful to use so that you can do your own processing of the models and the model scenarios in there. And then what's been sort of learned after the database have come out, that there is also this continuous quality control, that if there are now errors found or mistakes found, that through the GitHub feature of reporting certain issues, actually people find issues, they report them, and then they can be corrected in the database, and there can be new releases that actually have dealt with those issues that have been reported. So there's now sort of a continuous quality control also by the community and by the users to make sure that the database is up to standards. So this is where we are at the moment with the current tools. If we look forward to AR6, what's coming, there are at the moment 2 calls for scenario provision out there, or actually 3. So one for global scenarios that Lev already mentioned for the global chapter in the IPCC. There's also a call for national scenarios out there, so for national and regional emission pathways that look into the implementation and the evaluation of policies. So if you have scenarios for your country or region, please submit those to this database so that it can be included in the IPCC assessment. There actually is also a call out for the buildings chapter in the IPCC. So on those sectoral chapters, there's one chapter at the moment that has a call out. And I'm not sure whether there will be more to follow, or, but at least for now, this is for building-specific scenarios. And then, for the database that will be used for the AR6, there will actually be much more automation and of the processing on the back end of the scenario. And those of you who were in the method session earlier this week have seen the extensive talk by Matt Giddon on all these new tools that will be used to post-process the scenarios. But this pipeline of doing the assessment, where you have individual scenarios going in on the one end, and then the steps of harmonization of the scenarios, the steps of filling in missing data, and the coupling to climate models, to post-process, to diagnostics, are now all being automated with open software as well, and I'll go into those in a minute. And then at the end, you have like your assessment actually coming out. And so the need for harmonization, here you see that scenarios go in, but already in the base year, if you look at AR5, there's a wide variation actually of the models reporting their CO2 emissions for historic years that actually vary over quite a bit of a range. And so there is a need that if you feed this into a joint assessment that you actually harmonize your assumptions and do that in a transparent way so that everybody can actually see what the consequences of this harmonization are. Also, many models actually have only, for instance, CO2 or only other gases that they report and not all of the gases that you need in order to do a climate model run. And so there are methods to increase the coverage. You know, 100% of the models report CO2, but you see only 40% or so report the HFCs. And so there are now methods in development to fill these gaps so that you can also go from a CO2 only scenario towards towards a full climate assessment. All these tools are linked with the database, but they are also all available on GitHub, reported and openly available for everybody also to contribute to and to work with, so that you can actually help with the development of these tools and and use them for your own research. And this is really a community effort to build these tools, right? This is really not only one institution or a small group of people that is able to pull this off. So all of your joint and a collective energy and knowledge on these kind of things is really appreciated and needed in order to develop this into a very useful suite of tools for our whole community. A few details on the tools that quick examples on the tools that are in development. So for instance, on the harmonization here, this is the ANARIS tool that does the harmonization of Bayesian assumptions based on different approaches that you can choose, whether you have like a constant offset over time, if you only have a small a difference in the Bayesian, or if you have a constant ratio of the difference from the Bayesian, or whether you have some convergence over time, and you can choose those now transparently in this software method and also report how you actually have done your this harmonization. The infilling, the details again were in Matt's talk on Monday, but this is the silicone tool for the infilling, which is and then this matches based on how we see in other scenarios how emissions of CO2 can be related to emissions of other gases, and then tries to find sort of the least or the closest scenario that you have to the scenario that you have submitted, and then sort of assumes how you can fill in for the other gases. And also here there are different ways of doing it, and the software allows you to actually choose the different ways to do it and report transparently on how you did it, rather than that it's happening in the back, intransparently in a black box. Interfacing with the climate models with the OpenSCM tool, also trying to standardize the interface going from the databases that, with the integrated assessment scenarios towards the use with simple climate models, so that you can basically link any integrated assessment model scenario with any simple climate model to do the climate assessment. So this will be used in the assessment, but you can use the software also to do it with your in your own research and your own studies. And then if you compare basically what's going on for AR6 with what happened earlier, you know, we see that we're going to have harmonization of the data to a more recent year. We have we used to do the harmonization based on the RCP database that had been developed about a decade ago, and now there will be a new CMIP6 database for historic data. The methods are now much more customizable and open. Infilling method based on this, on the software, will be much more customizable and open, and linking to the climate assessment is also not only magic anymore, but is now open and can be used with multiple simple climate models. And also the requirements for emissions that go into the database in order to be able to actually contribute to the full assessment are also reducing from, well, you need to actually submit like an almost full scenario to, well, if you have a CO2 fossil fuel and industry scenario only, with these infilling methods we can at least impose to some extent, with all the caveats that are around that, the other gases and do a full assessment. So, to wrap this up, the most important deadline is for the ones of you who are producing scenarios and are either considering to submit them or have already submitted them, is this June 15 deadline for submitting scenarios to the database, but also to have your paper that comes with the scenarios actually submitted to the literature. And there are a few decisions and discussions that will be taking place between the community and the AR6 on actually what do we do here in terms of regional scope, what do we do with gases, how can we harmonize or keep open the configuration of these different tools, right? How do we, the different methods of harmonization, the different methods of infilling, how much should we standardize, or can we keep different methods to use within the assessment? And then if you want to work with the existing tools, the existing 1.5 degree scenario explorer, here are a series of the resources that are now available to work with at this moment out there, that you can use to either look at existing scenarios and use in your own assessments for your own scenarios and comparing your own scenarios to the literature. So with that, I want to thank you for your attention.